All right, so you know how you guys are always sending us super interesting stuff?
Mhm.
Well, this time you really outdid yourselves. Someone sent in this piece.
Yeah, okay,
It's
yeah.
from March 2025 by Shiva Narayan Takshila Page, and it's called Brainpage Modulation, Strengthening Neural Connections for Mathematical Intelligence.
Wow.
I know, right? Just the title alone had me hooked. I mean, who wouldn't want to boost their brain power when it comes to math?
For real.
So we're diving deep today to figure out what this brain page modulation thing is all about and how it's supposed to help us become like math whizzes or something.
Yeah, when I first glanced at this, the thing that immediately jumped out at me was like how it breaks down mathematical ability into these two like fundamental parts.
Uh-huh.
There's that almost instinctual pattern recognition, that aha moment,
Mm-hmm. Totally.
and then there's that often much more, how should I put it, laborious process of calculation.
Ugh, yes. The struggle is real.
And the piece really drives home this point that so many of us can grasp the concept. Like we see the logic, but then when it comes to actually crunching the numbers,
It's like hitting a wall.
yeah,
So
exactly.
you can see the path, but then you get bogged down in the weeds.
And this is where brain page modulation comes in, right? It's
Yeah.
like it's offering a way to build a bridge between those two sides.
The source makes it sound like it's literally about strengthening those neural pathways in our brains.
Right, solving a math problem less of a conscious step-by-step grind
Right, right.
and more like an intuitive flow, almost like an extension of that initial understanding.
Yeah, and what's really interesting is how it points to these very specific brain regions.
Yeah.
Like the parietal lobe, hippocampus, and even the motor cortex are all supposed to be involved in this process.
The motor cortex, now that is fascinating. This idea of making mathematical problem solving more motor driven,
Yeah.
it really shifts the focus away from just pure cognitive effort,
Hmm.
like engaging different parts of the brain in a much more coordinated way.
It's almost like a whole brain approach to math.
Exactly. And the piece hints at three core mechanisms
Right.
that supposedly make this happen. And I think unpacking those will really give us a better grasp of how brain page modulation might actually work in practice, like in our daily lives.
Okay, so let's get down to brass tacks. How does this brain page modulation thing actually function?
Well, the source lays out this core idea of essentially transforming what we've learned in math, all that knowledge, into these like motor-based neural circuits.
So it's not just about knowing the facts.
Right.
It's about somehow embedding them into our like muscle memory almost.
It's about taking all those deliberate step-by-step processes and making them almost unconscious, almost automatic. Think of it like when you first learn to type.
Mm-hmm.
You're thinking about every single letter, where to place your fingers. But with practice, it just flows, right? Your fingers just know where to go.
Yeah, that makes sense. It becomes second nature.
That's what brain page modulation seems to be aiming for with math. That same kind of deep procedural learning for mathematical operations.
Cool. So the source breaks it down into three key mechanisms, right?
Right.
Let's take a look at those.
Okay, so first up, we have thalamic relay and cyclozeid rehearsal.
Say that 3 times fast.
Thalamic relay and cyclozeid rehearsal.
TCR. Okay, that's easier.
TCR.
Now, the thalamus, if I remember correctly, is kind of like the brain's grand central station. It
Mhm.
directs all the incoming sensory information, right?
Exactly.
So how does that play into processing math efficiently? It doesn't seem very mathematical.
Well, that's where it gets interesting. The source describes the thalamus as this relay station that basically ensures smooth and efficient processing of mathematical information as well.
So even math data has to go through customs.
In a way, yes.
Yeah.
When you're trying to make sense of, say, new number sequences or a new equation, the thalamus is involved in filtering and directing that information to the right parts of your brain.
Okay, so the thalamus is like the air traffic controller for all the math stuff flying around in our heads.
That's a great analogy. Now, the cyclozeid rehearsal part, that emphasizes the cyclical nature of this whole process.
The cyclodo definitely suggests something repetitive.
It's about engaging with numerical operations over and over again, almost like a constant feedback loop in your neural networks.
Okay.
This thalamic cyclozeid rehearsal, or TCR, it's presented as this kind of mental workout, specifically designed to strengthen those mathematical brain page circuits.
So we're literally talking about like mental reps for our math muscles.
In essence, yes.
Now, the source calls this whole process TCR linography, and it talks about repeating numerical operations until like The solution just becomes intuitive. It's like
Yeah.
when you see 2 plus 2, you don't even have to think about it. You just know it's 4.
Right. And the source highlights how doing this actually impacts your brain's physical structure.
Whoa, really?
It strengthens the connections in the parietal lobe and the angular gyrus, which are like the key players in number processing.
So the more we do this, the more we're hardwiring those pathways for math.
Exactly. And by building those more direct and efficient routes to access numerical information, you're also reducing your dependence on working memory.
You mean that, like, mental juggling act we're always doing?
Precisely. It's like you're freeing up space in your mental RAM.
Oh, I like that analogy. So TCR is essentially building that foundational automaticity for math, right?
It's like laying down the groundwork.
That example of a pianist internalizing finger placements through practice, that really clicked for me.
Yeah, it's a great analogy.
It's the same idea as a student doing their multiplication tables over and over.
Until it becomes second nature.
Exactly. The answer just pops into their head.
Yeah.
So we've got the thalamus doing its traffic control thing, and we're doing our mental reps with TCR. Now, this second mechanism, it's called motor science and procedural learning for calculation.
Ah, yes. This one is where things get really interesting.
It sounds like we're moving beyond just thinking about math and into, like, actually doing something physical.
Exactly. The source is proposing that mathematical problem solving isn't just a cognitive activity.
Yeah.
It actually involves a kind of motor execution in the brain.
I've never thought about it like that.
It might sound counterintuitive, but think about it. Even just writing down a math problem engages your motor skills.
That's true, I guess.
So the source brings in the cerebellum and motor cortex, which we typically associate with like physical movement.
Right, walking, talking, that sort of thing.
Precisely.
But how do those areas play a role in something as abstract as arithmetic?
Well, the source suggests that automating those arithmetic operations, it's kind of like learning any other motor skill, like riding a bike.
Oh, okay.
With enough practice, it becomes ingrained in your procedural memory. The cerebellum helps refine and coordinate these like mental movements involved in calculation, while the motor cortex helps with actually executing the sequence of steps.
So even though we might not be physically moving, our brains are still engaging those motor pathways when we're doing math.
That's the idea.
Fascinating. So how does this motor science angle actually translate into better math learning?
Well, the source specifically mentions engaging handwriting and active problem solving as being key.
So ditch the calculators and pick up a pencil?
It seems that way, yes. The act of physically writing out math problems, it provides a richer sensory experience. It's like you're adding another layer of input to help build those brain page circuits.
Yeah, it's more active than just staring at a screen.
Exactly. It makes the learning process more embodied. This, in turn, helps enhance what's called procedural fluency, making those calculations more automatic, more ingrained in your mental processes.
And the source also points out that by strengthening the cerebellum and basal ganglia, we can actually reduce the cognitive load we often feel when tackling tricky calculations.
Right. Those brain regions become more efficient at handling the routine stuff.
Like they're taking over some of the heavy lifting.
Precisely. So our conscious minds are free to focus on the bigger picture.
That makes a ton of sense. That example of someone learning long division by writing out the steps until they can do it in their head, that's a perfect illustration of how this works.
It's the progression from conscious effort to automatic execution.
Right. Okay, so we've got the thalamus keeping things organized, the motor system getting involved in automating calculations. Now, what's this third piece?
Right. The third key mechanism focuses on the hippocampus.
Oh, the hippocampus, memory central.
Exactly. Hippocampal memory consolidation for formula retention. That's what the source calls it.
So how does Brainpage Modulation leverage the hippocampus for math specifically?
Well, the hippocampus, as you mentioned, is essential for memory. It plays a vital role in storing and retrieving all those important mathematical formulas, rules, and problem-solving strategies.
It's like our mental math toolbox.
A very apt analogy.
Yeah.
And Brainpage Modulation aims to strengthen this entire process of storing and retrieving through what it calls structured repetition and active recall.
So it's not just about cramming information in there.
No, it's about building a really robust and easily accessible library of mathematical knowledge in your brain.
Like having all the right books and knowing exactly where to find them on the shelf.
Absolutely. And the source mentions something really interesting called spatial mapping.
Spatial map.
The idea that the hippocampus actually organizes math knowledge spatially.
What does that even mean?
Well, think about it like organizing your physical workspace.
Oh, okay.
If you have a system for where you keep your tools, your materials, you can find what you need much more quickly.
I see.
The hippocampus seems to do something similar with mathematical concepts. It creates a kind of mental map that allows for more efficient retrieval.
So it's like a mental filing system for math,
In a way, yes, and then there's neural rehearsal.
which is basically just doing lots of practice problems,
Right.
right?
Well, it's more than just rote practice. It's also about actively trying to recall those formulas without looking them up. This process strengthens the connections between neurons, making recall faster and more reliable.
The more you use it, the stronger the pathway becomes.
Exactly.
And the source also mentions the role of emotion and motivation.
Right.
How do those factor into memory consolidation?
Well, when you have a positive experience while learning, your brain releases dopamine, which is a neurotransmitter associated with reward and pleasure.
The feel-good chemical.
Exactly. And this dopamine signal actually strengthens the memory of that experience, making you more likely to engage with that activity again in the future.
So if you're having fun while doing math, you're more likely to remember what you've learned.
That's the idea. It's positive reinforcement. This makes learning formulas less stressful and more enjoyable, which in turn leads to better retention.
That chess player analogy really resonated with me, how they can just instinctively recall all those moves and strategies after years of practice.
A great example.
It's like that student who's used the quadratic formula so many times, they can practically recite it in their sleep. It's become a part of them.
It's deeply ingrained. So we've seen how each of these mechanisms works individually. The thalamus for efficient processing and rehearsal, the motor system for automating calculations, and the hippocampus for solidifying those memories of formulas and strategies. But the source really emphasizes that it's the integration of all three that's the real game changer.
It's like they're all working together in concert.
Exactly.
Yep.
Cyclozeid rehearsal, motor science, and memory consolidation, all three working in synergy to boost your mathematical intelligence.
Okay, so let's break down the benefits. The source talks about enhanced pattern recognition, with the parietal lobe and thalamus teaming up to help us spot those underlying structures and relationships in math.
Right. It's about training your brain to see those hidden patterns more easily.
And then there's the boost in calculation efficiency.
Yeah, with the cerebellum and motor cortex making those basic arithmetic operations more automatic, freeing up our mental bandwidth for more challenging tasks.
Less mental strain, more brain power for the tough stuff.
Precisely. And of course, there's the improved formula retention thanks to the hippocampus and angular gyrus, making it easier to recall those crucial rules and methods when we need them.
It's like having all the right tools at your fingertips, ready to go.
It's about creating a more efficient and integrated system for mathematical thinking.
Really powerful stuff.
And this is what Brainpage Modulation, particularly through this TCR framework, aims to do. Strengthen those fundamental neural connections that make all of this possible.
So it's about building a better, faster, more intuitive math brain, essentially.
And that's what leads to faster processing of numerical information, effortless recall of formulas, and those automatic calculations that can be such a hurdle for so many people.
It's like unlocking your math potential. The source's conclusion really brings it all home. It emphasizes that effective mathematical learning isn't just about those moments of insight, about seeing the patterns.
Right. It's equally about being able to translate that understanding into action.
To accurately and efficiently solve the problem. It's the seeing and the doing working together.
And Brainpage Modulation aims to optimize those connections, making problem solving more intuitive and, as the source puts it, more motor-driven.
It's like tuning those abstract math concepts into something your brain can really grasp and work with.
It's a shift from seeing math as this purely cognitive burden to something that feels more natural, more integrated with your overall thinking process.
It's about bridging that gap between that initial aha moment of understanding and actually having the skills to execute.
Exactly. It's about transforming that pattern recognition into genuine problem-solving ability.
And this is where it gets really personal.
Yeah.
The source directly addresses anyone listening who might feel that frustration of, seeing the patterns, understanding the concepts, but still hitting a wall when it comes to the calculations.
Right.
They get you.
They do. And they present Brainpage learning as the solution, the bridge
Right.
that can help you strengthen those neural connections.
So that you can solve problems faster and recall information more easily.
It's like they're giving you the tools and the roadmap to overcome those hurdles.
Powerful stuff. So let's recap our deep dives today. We've explored this idea of brain page modulation from Shiva Narayan Takshila Page's work. We've looked at how it aims to make us better at math by focusing on these three interconnected mechanisms.
Right. First, there's Thalamic relay and Cyclozeid rehearsal, or TCR.
Which is all about efficient processing and mental rehearsal.
Right. Then we have motor science and procedural learning, which brings in the motor system to automate those calculations.
And lastly, there's hippocampal memory consolidation, which focuses on strengthening our memory for formulas and strategies.
And the key takeaways, the call to action from the source, are really straightforward.
First, we need to consciously work on automating those basic arithmetic operations.
Right, using that motor science approach we talked about.
Second, we need to actively strengthen our memory for formulas through brain page rehearsal.
Those mental reps are crucial.
And finally, we need to aim for that seamless integration of pattern recognition and calculation fluency.
Bringing those two sides of math together.
Here's something to ponder as we wrap up. This whole idea really highlights how mathematical fluency isn't just about having that flash of insight, that eureka moment.
It's not just about seeing the patterns.
It's also about those often overlooked aspects of effortless calculation and reliable recall. Think about how intentionally applying these concepts to your own life, focusing on strengthening those neural connections, how that might not only boost your math skills, but also have a positive impact on other areas of your thinking and problem solving.
It's about expanding your cognitive abilities.
And here's where it gets even more interesting. The source actually touches on this idea of mathematics as the deep structure of intelligence and reality in a section called TCR Beyond Numbers.
Really?
It's like they're suggesting there's this much wider, deeper potential for this kind of brain training than just acing your next calculus exam.
Wow.
It's food for thought.
Definitely. And if you're intrigued by all of this and you want to dive even deeper, the source recommends checking out the Takshila page.
They have more information on something called system learnography.
Sounds intense.
It's like a whole system built around these principles.
Fascinating.
Well, thanks for joining us on this deep dive.
It's been a pleasure.
Until next time, keep those brains buzzing.